two types of questions for f dash x and fx function. So I can ask you sketch f dash x function from fx. I can also ask you to sketch fx function from f dash x. So there are two types of questions in the VC exam, normally multiple choice questions, from f dash x to fx and from fx to f dash x. So let's have a think about that. I use the space below. If it's fx to sketch f dash x, okay, and if it's f dash x to sketch fx, okay, what do you look at? So on fx graph, what do you look at? If it's, you have fx graph and you want to sketch for f dash x, what's the first thing you look at? Stationary points. Okay, what stationary points will becomes to on the f dash x graph? 0, so another name. 0, yeah, what 0? Yeah, 0, so what equals to 0? X equals 0, y equals to 0. So it's x-intercept. Okay, so stationary points, the x value becomes the x-intercept. Yes, it cuts the x-axis, no problem. So that becomes x-intercept. What other things you also look at? It's not enough. I know my x-intercept on f dash x is not enough. What other things you look at? Yeah, so it's increasing or decreasing. So if it's increasing function, what the f dash x, how to reflect that on the f dash x? So it will be positive. So it will be above x-axis. Yeah. So it's positive, that will positive gradient, increasing function is positive gradient, and it will be above x-axis. Okay, how about this decreasing function? Yep, below x-axis. Okay, how about I have horizontal asymptotes? Like I have horizontal asymptotes y equals to a. How this will reflect on the f dash x graph? Well, say if you have a graph looks like this. Well, on this side, it will approaching to this y equals to 2. Yep, asymptotes at 0. Okay? Okay, so anywhere you have horizontal axis, on that same side, you will have horizontal asymptotes at y equals to 0. Because finally, your gradient is approaching to 0. Okay, you talk about gradient. Because when it's approaching to any asymptotes, the gradient will approaching to 0 anyway. So you won't have the horizontal asymptote stay at that place. It will become 0, okay, on the gradient function. Okay. How about if I have vertical asymptotes? Well, x equals to b. Yeah, so how this will reflect on this side? What do you need to show? You still have the asymptote at the same point. Okay, you still have, because that point is still undefined. Doesn't matter whether on the original graph or the new graph, that point is still undefined. So you still have x equals to b as the vertical asymptotes. Okay, that's all the things you need to know from the fx graph to f dash x graph. Okay, so as easy as that. So from that to that, you will see 1, 2, 3, 4, 5 things. Do you have that? Well, definitely you have 1, 2, 3, but maybe not 1 even. You will have 2, 3 definitely, increasing or decreasing. But like you might not have horizontal or the vertical asymptotes. That's fine. That's some advanced things. But when you have f dash x to look back for fx, what you need to see from the f dash x function is exactly those things. Okay, you just copy everything again. Do you have that 5? Well, what's the 5 things showing on the f dash x graph? Do you have x-intercepts? Is that above x-axis or below x-axis? And do you have horizontal asymptotes and do you have vertical asymptotes? When this go back, x-intercept would become stationary points. When it's above x-axis, is increasing. When it's below x-axis, is decreasing. And when you have y equals to 0, you will have horizontal asymptotes somewhere. I don't know where, but it will have a horizontal asymptotes. And also equals to b, I will still have x equals to b at exactly the same point. But it's not enough. All of this information needs to put into the sign table. Okay, it's easy to sketch. Okay, I will put an easy, difficult. Okay, it's easy to sketch from fx to f dash x. I just can look at it and then sketch it. But from f dash x to fx, yes, I can see all this information, but all the information needs to be put in a table. And from the sign table, I can sketch the original graph. Remember we did this type of question before, like we see the f dash x function and I put, okay, stationary point is here, here, and here. Okay, what's in between that, what's in between that, and in between that, and I put all the values in. So I will need the sign table for that. It's a revision, okay, it's nothing new, like what all I said is revision here. You don't need to remember the thing above, that's just an example what things should look like, but you can all do in the same method. Okay, you don't need to remember that, that's just examples there. Okay, and I have talked about all of that above. So what all you need to remember is the bottom, what I write here. Okay, it's the bottom here. Okay, let's have a look at the questions. It's about calculation and the graph. Okay, let's have a look at example 6 first. It's an easy one. Okay, let's look at example 6. Sketch the graph of the antiderivative of the function given that it passed through the origin. Well, I don't care about what is given yet, because you know, like, you need a point to be sure, like, where the actual fx looks like. Otherwise, it can go up and down. Like, there will be infinite many values. Why f dash x can go back to infinite many fx? I need a point to make sure where is actually that graph. So that's what the information used for. But anyway, let's have a look at this one. As I said, I need to put everything in a table. Okay, I'm marking the papers, like for the set papers. I realized the problem. Do you know what the 3 columns should be, like 3 rows should be? What's the top one? What's this variable? Okay, it's the horizontal. Okay, it should be the horizontal value, not only x. Well, if x is the vertical, it can't be x. Remember the question is xt. Like there's one question which is xt. You should put t here and x dash t here. A lot of you just well, I don't know what you sub in, like just really random thing. Like you put x there and the x dash t here. I don't know what you actually want to sub in. Like, and the value sub is incorrect. So it's the horizontal values, okay? So, okay, so for the sign table, you need to sub horizontal value here. So the horizontal value should be x. And you should sub the derivative, okay, d vertical, d horizontal. So in this case, it's dy dx. Okay, this function is dy dx. Okay, it's not x, not y, it's dy dx function. It's the derivative and ask for the antiderivative. And the last line, well, you can write nothing or you can put like graph. there. Like, it doesn't really matter. But important is the first two, like the notation for the first two. Okay, what we need to do here is we leave the first empty and we see, okay, we need to see x-intercepts. We need to see whether it's above or whether it's below x-axis. And I see horizontal or vertical asymptotes. That's all the things I need to see from the derivative graph. Okay, if I want f dash x to sketch for fx, I don't care about the turning point in dy dx. So I have x first empty, the second one I have -2, the third one I have 1 empty and 1. So I should have my table set up in that way. So dy dx give you 0 and 0 here. On the left hand side of -2, okay, on the left hand side of -2, I should have -2, I should have negative, okay, below, so it's negative. Okay, below the x-axis, the derivative is negative. So it's decreasing. And horizontal here, in between -2 to 1 is positive, and it's increasing. And horizontal, and in between after 1 you have below. Okay, it's below, it's not only decreasing, it's below, so I will have negative and it's decreasing here. So you can see this shape. It's that shape. This point is -2 comma something. This point is 1 comma something. If I do that, okay, that will be y-axis. Because -2 is here, 1 is there. So this part, this will be my y-axis. And then because it passed through 0, 0, then my x-axis will be here. Okay, because it passed through 0, 0, then my x-axis must be there. So the graph looks like this. Well, I can't find the other, like, this is not 1, 0, it's 1 comma something. So I can't find those two. I have no further information for that, but I know this point is 0, 0. It passed through the origin. The vertical axis must be there because -2 is here, 1 is here, and it's 1/3 away from 1. Questions? Okay, you need the table to go back from f dash x to fx. If you have no problem with that, can you sketch for 7, please? Do not confused with what you need to look at for fx graph and f dash x graph. You look at completely different things, okay? Look at completely different things. When you finish, you can have a look.
I know that. Let's keep it up. It's all right.
Finished. We need to look at the x-intercept. This is a derivative graph. We need to look at the intercept. So we look at -2 and 0. Okay, we look at -2 and 0. So we put -2 and 0 at those two spots in order. Then on the left of -2 is decreasing. In between -2 to 0, still below the x-axis, still decreasing. And after 0, it should be positive. It's above the x-axis, so that's increasing. So we have stationary point of inflection at the point -2, and we have a lowest minimum turning point at 0, 0. Okay, so it also passed through origin, so I know that's 0, 0. Okay. Okay, if we finish that one, go to page 23. There's a U-turn question. Okay, it's your turn to do it. The derivative graph looks like this. What's the antiderivative function? Okay, A, B, C, D, E. That's easy. You pick one. Okay, it will be the same. Okay, you still need to do the same thing. Okay, who think is A? B? C? D? E? F? I don't know. Okay, most of us select A. Let's have a look. Oh, what? A is correct. Okay, A is correct. Too scared you. A is correct. Okay. So let's have a look at this question. You have this derivative function. So I have 0 and A. This is a good one. I have 0 and A here. Because it's x-intercept. I have 0 here and A here. That's the 2x-intercept. On the left-hand side of 0, you have negative function. In between 0 to A, you have positive, and after A, you have negative. So the function should be decreasing 0, increasing 0, and then decreasing. And also this shape. Can you see there's horizontal asymptotes at that side? So on the same side, I should have horizontal asymptotes as well. Well, it's not necessary at this y equals to 0. It will be somewhere. I don't know where is it, but it will be somewhere. But the asymptotes definitely exist there. So I have horizontal asymptotes, but I still show decreasing function. Okay, that's the only way to show is decreasing function, but also have the horizontal asymptotes. And then I have minimum turning point at 0, 0, and at 0 something, not 0, 0. And then I can have maximum turning point at A something. Okay, so that's what the graph looks like. So A is the correct one. B looks very similar, but like A labeled at the wrong place. A should be the turning point, not the x-intercept. Like when it is x-intercept in the f-x function, it's not going to be only x-intercept on the fx function. So it needs to be stationary points. So A must be a stationary point. That's why you should reject B and then select A. And then C, D, E, they don't have the same shape. Like they don't have exactly the same shape as what I sketched there. So they can't be correct. So correct answer is A. Alright, go to which one? Let's see. Well, I want you to do 5 by yourself. Let's do 8. Now have a look at 8. A side, find the equation of the curve defined by dy dx equals to e to x, given that the curve passed through 0, 5. Okay, it's very, very easy actually, this exercise. I just separate from exercise A with you. You know, like we should have a plus c value at the back every time we do an indefinite integral. And then if give us a point, I can find out what's the c value by substitute that point in. So what this one should looks like is y equals to the integral of e to x of dx. So y should be a half e to x plus c. Then you know when x equals to 0, y should be 5. So 5 equals to half e to the power of 0 plus c. 5 is a half plus c. C is 9 on 2. Okay, so this is only thing I want to talk about here. We just need some point to find c values. Well, I can give you any point. Well, in this case, I got c equals to 9 over 2, and I just write y is a half e to the power of 2x plus 9 over 2. Any questions for that? Okay, let's have a look at the next one. A population of koalas is increasing according to this law, dp/dt equals to 100e minus 0.1 t. Okay, I just let you know, a lot of modeling for populations will use exponential to do that, because exponential will go horizontal asymptotes and will restrict, like it's not going to be increased forever. You can be restricted like there, because you know, like for any population you can't just keep increasing. There will be a limit point, like for example, maybe because of the food, because of some other things like disease, like it won't really go forever. It can't so go infinite many population after like 100 years. It's just not going to happen. So to model population, exponential will be a good thing, because you have the horizontal asymptotes and will restrict the increasing, will restrict it to a point. Okay, so we'll stay there. So for this one, first exercise give you have 5 koalas initially and find the expression in terms of p and t. So p will be the integral of 100e minus 0.1 t dt, and p will be 100 times 1 over negative 0.1 times e negative 0.1 t. Okay, divide by 1, divide a, so times 1 over a. A is the coefficient of t, which is 1 divided by negative 0.1. So that's a negative 10, right? That's a negative 10. You times 10 on both top and bottom, so that's a negative 10. So P is negative 1000 E minus 0.1 T. You have 500 koalas initially. Initially means T equals to 0. So T equals to 0, P equals to 500. T equals to 0, P equals to 500. So 500 equals to minus 1000 E plus C. Okay, sorry, I forgot the plus C here. So I have a plus C. And then that's to the power of 0 plus C. That's just a 1. So C is 1500. P is negative 1000 E to the power of minus 0.1 T plus 1500. Well, B asks you to sketch for this graph for the first 10 years. Well, if you don't think about the first 10 years, if I think about ongoing thing, you can see like I have a positive base. Okay, I'll just draw here. I have a base greater than 1, so I have increasing graph. But this A value and this K value, they're both negative. I will get reflected twice. Once horizontal, once vertical. So horizontal flip, I should have that. And then vertical flip, I should have that one. Okay, so my final graph should look like this shape, like below the horizontal asymptotes and also like increasing. So my graph should look like, well, I can't have negative time. And also I know that's 1500, that's 500. I know I should horizontal asymptotes here. ongoing. Okay, that's ongoing. Like, and I have initial value here, and I should increasing like this. Okay, that's the actual graph should looks like. And because this just asks you to sketch for the first 10 years, so I can just stop at a point here, say that's 10 comma minus 1,000 over E plus 1500. Okay, just sub the value in, sub 10 in, top give you power of minus 1. That's 1 over E. And that's minus 1,000 over E plus 1500. But if you keep going, you just keep approaching to the asymptotes but never reach that point. You just keep going. And the last one is ask you once the population is 500. Just give me 1 minute, finish up that. You just solve that equals to 500. 900, sorry, 900. So solve that equals to 900. So 1,000 E minus 0.1 T equals to 600. Okay, move that to that side and move 900 to the left hand side. E minus 0.1 is 1 over 10. T equals to 6 over 10. So divide by that. And that's a 3 over 5.6. Minus 1 on 10t equals to log E 3 over 5. And t is a minus 10 log E 3 over 5. Just calculate for logs. Okay, you can also put the negative on top. So that's log E 5 over 3. You can flip it inside. Okay, just have a think about that like at home. We're just solving for logs.